Hello there, welcome to these notes on section 4.5. We're going to be starting on page 310. Make sure that you're on the right page so we can get going. Alright, so we're actually going to look at this first example. I'm just going to read through it. We're looking at different functions and how to represent them. We have a zebra's main predator is a lion. Lions can run at a speed of 53 feet per second over short distances. The graph at the right shows the speed of the zebra. Compare their speeds. So if you are stuck or confused on what exactly they're talking about, go ahead and label them. They just told you that the graph over here is showing the zebra. So this is the graph, and then they give you the different information for the lion. So there's our zebra graph. Now, the lion we know can run 53 feet per second. So you're actually going to kind of make your own, you can either make your own equation or maybe figure out the zebra, because I think that would help us compare them. Now, it says to compare their speeds, compare the rate of change. Make yourself a note over here on the side that rate of change is equal to slope. Rate of change is just another name for slope. Alright, so down here we have a lion can travel at a rate of 53 feet per second. That was given to us. There's really no thinking in that part. Now, to find the rate of change for the zebra, you need to choose 2 points. And I'm even going to highlight these because this is like your step-by-step process. So the first thing you're going to do is choose 2 points on the line. And then, after you choose those 2 points, you're going to find the rate of change between them. What does that mean? That means you're just going to be subtracting them. So if you look right here, I have 2 points, 1 comma 59 and then 218. All I need to do is take their y's, 118 minus 59, which they're doing right here, and then take their x's, which is 2 minus 1. So when I simplify that, I get 59 over 1, which really stands for 59 feet in 1 second. I know that because 59 is my y, which is the distance, and 1 is my time, the x value. So a zebra can run at 59 feet per second, and the lion is at 53 feet per second, so we can tell that one is faster. All right, let's do this example together. So we have a car that gets 22 miles per gallon on one car, and then we have a sports utility vehicle like an SUV over here on the graph. So if we want to compare their gas mileage, right here that tells me I need to find the constant rate of change or the slope from here. All right, so in order to do that, I need to first pick 2 points, subtract their y. So I'm going to end up doing 38 minus 19 over, and now this is actually the same as whenever we do y2 minus y1 over x2 minus x1, but it just kind of simplify it because if you're on a graph, it's way easier. And then you do 2 minus 1. So 38 minus 19 gives me a total of 19. And then 2 minus 1 gives me a total of 1. What does that tell me? That tells me that there are 19 miles in 1 gallon. Now up here you can see that we have 22 miles per gallon. So in order to compare these, I can just look at those numbers, make this one a little smaller, and I can tell you that, so the car gets 22 miles, the SUV gets 19, so the car gets 3 miles more per gallon. So that means that the car is obviously getting the better gas mileage. All right, and we're going to do another one. So we did a problem like this yesterday, and I'm going to go over another example here. So I have the number of 2 movies a store receives can be represented by this function, m equals 7w plus 2. M represents the number of movies, and w represents the number of weeks. The number of games the same store receives is shown in the table, which is right here. We're going to compare the functions y-intercepts and rates of change. So I'm going to start by finding the rate of change for both of them. So up here I have m equals 7w plus 2. Remember, rate of change is the same thing as slope. So slope for my first part is 7, and I know that because it's being multiplied with something. I make a line so I can write over here. Now, to find this slope, remember you need to find the difference. To get from 3 to 6, I add 3. 6 to 9, I add 3. Now on this other side, they're going up by 1 every time. So my slope for the table is m equals 3, or you can put 3 over 1, either way. Now, to find my y-intercept, from the equation, it's really easy because it's the number that stands alone. So that one right there is a positive 2. And my y-intercept for this table, which is sometimes harder to find because you do have to do a little bit of math. If you want to find your y-intercept from a table, you need to go backwards to 0. So if I go backwards on this side, I need to go backwards on this side. So I got 0 on this side because I did 3 minus 3. So the y-intercept here is 0. So we're going to compare the function's y-intercepts first. Their y-intercepts are 2 and 0. All right. So just so you know, we're talking about the number of new movies a store receives, which can be represented by this one right here. So that means the store, this equation, the y-intercept is 2 more. And then the slope, which is 7 and 3, well, 7 means that they are getting 7 movies per week. This one over here, this slope means that they are getting 3 new games. So we need to explain that. We can say that B means that the store starts with 2 movies and 0 games. Now their slope here, they start with, I'm sorry, not start with, but they get 7 movies every week. Let me space that out. They get 7 movies every week and 3 games every week. That's the explanation part. Now, if you look here, it says how many new movies and games will the store have in week 6? So we can figure that out if they get 7 new movies per week. So in 6 weeks. So I have 1, 2, 3, 4, 5, 6 here. So they start with 2, and then they add on 7 in the first week. So we have 9. And then the second week, we add 7 more to 9, which is 16. Sorry about my sloppy handwriting. 7 more when we add it on to 16 gives me 23. And then in 4 weeks, I have 30. 5 weeks, I have 37. And then that means in 6 weeks, I have 44 movies. So I'm going to write that up here, 44. I'll just put M for movies. Now I'm going to look at this table, and I can kind of just use this and extend it out. 5 and 6. So in 4 weeks, we're going to keep adding 3 each time. So 9 plus 3 gives me 12. And then 12 plus 3 gives me 15. 15 plus 3 gives me 18. So that means in those 6 weeks, they're going to have 18 games. I'll just label it with a G. All right, let's kind of read through this one. You can always go back and read it. So it says, Angela and Benjamin each have a monthly cell phone bill. Angela's monthly cell phone bill is represented by the function y equals 0.15x plus 49, where x represents the minutes and y represents the cost. Benjamin's monthly cost is shown in the graph. So we want to compare y-intercepts and rate of change. So if you look at Angela's bill, which is this equation right here, the y-intercept is 49. And from the graph right here, you can see Benjamin's y-intercept is 60. So Benjamin has a greater initial cost because he's going to pay that $60 no matter how many minutes he uses. And so now we're going to look at rate of change. Angela's rate of change is 15 cents per minute. We get that from her equation up here. And then Benjamin is where we actually have to do some math. So you're going to take points and subtract them. So you take, I guess they took different points. So let's look right here. They took 80 minus 60. They chose any 2 points. It really doesn't matter. And then 200 minus 0. So that's what they did right here. And then they changed it to a decimal and got 0.10, which represents that he pays 10 cents per minute. So technically, Angela pays more per minute than Benjamin. And then the final question, what will be the monthly cost for Angela and Benjamin for 200 minutes? Well, all you have to do is plug in 200 into Angela's equation right here, which is what they did. And then you can use Benjamin's cost. We know that 200 minutes, which is up here, is going to cost him $80. So that was already figured out for us. All right, and we will go ahead and do this example together.